one and all. Myself Archana BT, Assistant Professor in Dadi Institute of Engineering and Technology. Today we are having Kaushalendra Singh Sisodia, Director of Unique Converge Technologies as our guest. Overview of his profile. Sir has about 19 years of industry experience and he is the co-founder of Unique Converge Technologies Private Limited. Prior to UCT, he played various key roles in Ericsson, ST Microelectronics and other multinational companies. Under his leadership, UCT has been chosen by Nexus, University of Texas, USA Startup Hub, and collaborated with IIT Jodhpur and IIT Guwahati for commercialization of security and industrial IoT domain R&D products. Recently, UCT has been selected by IIT Roorkee for TICE acceleration program. He has been chosen by ATL Mission, Nitya Ayog, Government of India as mentor for Delhi Public School, Noida. Kaushalendra Singh Sir is IIT Kanpur alumni. He is a voracious speaker and delivered talks to many universities and colleges on Internet of Things, Industry 4.0, convergence of technologies and startup ecosystems. We are very grateful to have you, sir. Welcome, sir.
Initially, we would discuss about the evolution from 1G to 5G, and then the driving and motivational factors that are behind why we are moving from one generation to another generation in telecom. Then key concept of 5G. 5G applications specifically for IoT domain. Then we would see 5G architecture, present status of 5G worldwide. Then we would see conclusion, and in last we would have question and answer session. This is the evolution chart. We can say that every 10th of the year we have transited from one generation to next generation. In 1980s, when 1G was introduced, it was based on the analog voice, and the underneath technology was AMPS and text. After 10 years, we had 2G in 1990s, and it was based on digital voice, and underneath technology was the GSM and CDMA. So the GSM was introduced in Europe and CDMA was in USA. And it was the political reason that we had gone to two different kind of technologies. In 2000, after 10 years, in 2000, we had a 3G deployed, commercially deployed. And it was, the main feature was mobile broadband. We were having up to 34 kbps or 2 Mbps. That was the speed that we were getting in 2000. And the underneath technology was wideband CDMA, CDMA 2000, TDS CDMA, and WiMAX. So again, different kind of technology was adopted in different countries. So that's why we have multiple technologies. WiMAX was later on died out. WCDMA, CDMA, and TDS CDMA, they are still used. TDS CDMA mostly is used in China. It is again due to political reasons that they didn't wanted to adopt the same technology that other country was going behind. So they particularly adopted TD, time division multiplexing. Other were frequency division multiplexing, and this was time division multiplexing. Then after 10 years, we had 4G in 2010. It was a kind of enhanced version of 3G, where we had better and faster mobile broadband. So it was based on LTE, LTE Advanced, and 4.5G. In 2020, we are right now, we are talking about 5G, and here the biggest vision is the connected world. So here, instead of having a single technology, we are talking about connecting everything. So it would be handling the speed also, high throughput, as well as the applications that are going behind IoT. So this is towards the connected world. Even if we have the small throughput application or very high throughput, it should be addressed by 5G. Then this is another way of looking difference between the previous generation technologies. So in 5G we would be having 1000x mobile data. So that this is the volume. In compared to 4G, it would be 1000x. If we talk about connected devices, it would be 10x to 100x. And it would be 5 times having lower latency in compared to the previous technology. So latency and this connected devices, this is towards IoT when we talk about. And then we would be having end user data rate that is 10 to 100 times. The battery life would be 10 times efficient in compared to the previous technology. So these battery life, connected devices, and lower latency. These are towards the IoT application. Here we would be quickly looking into the exact the point-to-point difference between 4G and 5G. So if we talk about 4G, the latency was 10 millisecond, while left hand side it is 4G and the right hand side it is 5G. So 5G we have latency less than 1 millisecond. So this latency drives the throughput, ultimately throughput how much data rate we are achieving. And it is also important for the critical applications if we are talking about IoT. So latency is driving both the things, the criticality as well as the throughput part. Then the data traffic. Data traffic in 4G was 7.2 exabytes per month. Exa is 10 to the power 18. So these many bytes we were generating in 4G. On 5G, if we compare, it would be 50 exabytes per month. So this would be like we can see that almost 6-7 times more data we would be generating in 5G. The peak data rate in 4G was 1 gig per second. In 5G, it would be 20 gigabits per second. Spectrum used in 4G is 3 gigahertz. In 5G, we would be having 30 gigahertz. So we would be moving towards the higher spectrum side. So this because of the 30 gigahertz, if we convert it to wavelength, it would come into the millimeter side. So that's why 5G is called millimeter based technology also. And then the connection density, if we talk about the devices that would be connected, in 4G it is 100,000 connections per square kilometers. In 5G it would be 1 million connections per square kilometer. So this is the like major difference if we talk about different parameters between 4G and 5G. In terms of features wise, 5G would be having multiple numerology, because the bandwidth we can have multiple scales of bandwidth utilization. Then it is millimeter wave. Massive MIMO is the major feature. Beam management for speed or data on demand. We are having beam management, beam forming basically, and it better handles the interface scenarios. LDPC is the coding scheme, channel correction coding scheme that is being used. Then SDAP layer. This is because we would be having multiple services in 5G. One side it would be low throughput or IoT based services, other side it would be highly efficient throughput and like AR, VR and video on demand, that kind of services we have to run. So there are varied type of services that has to be handled, that is done by SDAP layer. Then UL waveform, subframe structure, HARC, these few things were already there. The blue one is little bit modified in compared to 4G. The red and yellow one are the new one. Then the SDN and NFB. So SDN is a software defined radio. Everything would be like in the network side also would be implemented in terms of software. And then network functional virtualization, that is also a new feature. It is SDN and NFB are very much tightly coupled, and they are like very much correlated to each other. So let us see the driving and the motivation factor, why we are moving from one generation to another generation. So basically everything is user or the demand driven. So for this telecom part, all the consumer side, we are the people who define the requirements. As the time is going on, we are needing more and more data rate, because we want to have a better experience. We want to have more apps running on our mobile. We want to have a different kind of services running. So if we talk about broadband experience everywhere, anytime, so that kind of requirement every user wants to have. Then the massive machine type communication. So when we say massive machine type communication, it is related to IoT, where there would be lot of endpoints that would be sending small chunk of data. The data would be very small per node, but when there are like huge number of nodes, ultimately the collected data would be huge. So that's why it is called massive machine type communication. Then mass market personalized TV like Netflix and video on demand, that kind of requirement is coming from the user side. And the critical machine type communication. So this is the one where the time is like very critical, where we have to take the action based on the parameter that we have captured. We have to take the action immediately. One example is healthcare. Another is the autonomous car. So autonomous car where all the data is going to a server and it is being shared between one vehicle to another vehicle. The everything is very much time critical. It has to be happen in a fraction of millisecond or in microsecond or whatever. So that way, that kind of real time processing is required for the critical machine type communication. So that was the user requirement. And then other than user requirement, there are economic and political needs also. So there is a committee that is called Committee on Digital Economy Policy. They have clearly stated that 5G, we should have 5G, and the objective of 5G is to increase GDP, creating employment, and digitizing the economy. And the another commission, European Commission, they are also talking of in the same terms that 5G should be used for digital transformation of industries, maximal economic growth. This is the economic and political region. And here they say that these aims will not only be achievable if 5G is designed such that it meets the requirement of all industry sectors. So basically this 5G is meant for all the industry sectors. We cannot like make 5G only a few of the segments. That's why the 5G becomes very complex in multiple dimensions. Had it been a single dimension where we have to support only very high throughput, high data rate, then it was easier to design. But here we have to design 5G in such a case that it can serve all the industrial segment, all the requirement from all the industry. So we have seen the user requirement, we have seen the economic and the political requirement. The third one is the technical requirement, how 5G is required at this moment. As we have seen in the previous slide, that every 10th of the year, the new technology, new generation was coming. So the first LTE network was deployed 8 years back. So there was again requirement for having a new generation of services. So that's why 5G required. Then data consumption continues to grow as consumers make more use of mobile broadband. Even if we have like earlier we had 3G, it was good, but after some time we also started complaining that we are not getting the data rate whenever we require. Then 4G came. Initially we were happy, but again after some time everybody started complaining. So there is like always the dearth of more data rate, or there is always requirement for the high data rate, because this data rate per cell is a shared service. As soon as initially there would be less users, it is good. It is every user would be getting high data rate. But as soon as more users are connected, the data rate would be shared among all the users. So thus, after some time, the data rate would be a little bit slower. So we would be needing more data rate, or we would be needing the new technology that would serve more users. Then the Internet of Things, it is resulting connection of billion of devices. So right now there is no technology that can serve this kind of need for coming from the IoT side. And there are some more requirement for the public safety and automotive. And we have to improve the spectrum and energy efficiency. That is also one requirement. So for that point of view, 5G is also being designed. And moreover, it takes many years to design a new generation system. So that's why 5G was well planned in time, so that the deployment can happen by 2020. That we will see in the coming slide that how it was planned. So this is basically the technical needs of the 5G. So here there is a statement that existing technologies are capable of satisfying today's requirement, but not those of tomorrow. So right now 5G is planned for the data rate or the requirement that would be coming from tomorrow. So that's why we have to take action today, so that we can be better prepared for coming time. If we talk about what is 5G, it is not really about connecting people. So it is more than that. It is about to connecting things. So 5G is like more addressing the IoT applications. And why the 5G came to 4G, they were talking about only the high throughput. But in the parallel, there was some other technology, other wireless technology also started becoming popular because of IoT. One is that LPWAN, that is LoRa. So LoRa, Sigfox, and there are some many more ad hoc wireless technologies. Those have started becoming very much popular. So 5G community, they, or the 3GPP community, we can say, that is driving 5G basically, they became little bit worried that if these other wireless technology would start becoming popular, it would be, and the kind of volume in IoT is much more than the volume we have for the connecting the people. So that's why the 5G was like fully evolved. The 3GPP had fully evolved their 4G architecture or whatever legacy architecture they were having to have to address the upcoming requirements that is from IoT side. Basically, this 5G use case are addressing the enhanced mobile broadband, massive machine type communication, and ultra reliable and ultra low latency communication. So these are the three things we can think about. The middle one is for IoT. The first one is the legacy that we have been running from 1G to 4G. And the last one is, it's kind of combined cellular one that we were having earlier and IoT. So that way, this is the chart or this is the different placement where we used enhanced mobile broadband. So here the data could be available in gigabytes in a second. 3D video, work and play in the cloud, or augmented reality, industrial automation. So these kind of applications can be done using the 5G, and it is like self-driving car. It is coming towards the ultra reliable and low latency communication side. So this graph shows that which application is towards which kind of domain. Then this is the digitization opportunity that is being shown by 2026. So by using 5G, the manufacturing industry would be having the most number of and caching of the opportunity, that is 19%. Then comes the energy and utilities, and then public safety, public transport, healthcare, media and entertainment, automotive, and financial services. So these are the different categories of services that would be utilizing 5G for digitizing their domain. Overall, the addressable market potential is 34% in revenue growth if we started using 5G. So far we have try to understand the requirement, the motivation about the 5G. So what is the performance requirement? So if we start using 5G, what kind of parameters, what kind of features it should have so that it can serve the requirement that we have discussed earlier. So it should have new radio interface. Since we are talking about multiple services, so radio interface should be introduced or should be designed freshly. Then we should have evolved LTE radio interface, new core network, and the evolved LTE core network. So these are the few components addressing the design requirements. And in terms of the priority, which one we should implement first, the enhanced mobile broadband and the ultra reliable and low latency functionality, those are the high priority things. So those kind of requirement would be fulfilled first. And in the later stage, the massive machine type communication and more comprehensive ultra reliable low latency functionality would be addressed. So they have divided into the different like milestones that they would be achieving at different times. Let us see the 5G architecture now. Let us start with 4G architecture. So in 4G or any wireless communication, we would be having one mobile, and then the mobile would be communicating to the base station or to the tower. In different technology, this tower is called with different names. GSM, it is called base station. 3G, it is called node B, and 4G, it is eNode B. eNode B is the tower where the mobile is directly communicating, and mobile is called user equipment. And then this base station or the node B, it would be further communicating to the core network. And in core network, there are multiple components that define it should be used for the billing and the home history, the mobility management, handover. So there are multiple things that has to be handled by the core network. So these are different interfaces. We will not go in deeper, but you have to see that this MME is the mobile management entity. This is serving gateway, packet gateway. Here interface is even simplified. If we talk about 3G, it is much more complex. So the in 4G we have simplified all the architecture because here we handle only the packet part. In 3G we were supporting voice as well as packet. That way it is simplified. Now how it would be evolved for 5G? Let us see here. In 5G we would be having a new base station that is called 5G New Radio GNB, and the core network we would still be using same for in the starting time, but later on we will move to 5G NGC, new generation core network. Initially we would be using same interfaces that so that it could be the SG transition. So this shows the 4G to 5G migration, the same thing that we discussed earlier. So there could be two paths when we move. We can upgrade the enhanced packet core or the core network. Path one is the upgrade existing EPC, that is from 4G, or the path two could be the introduce overlay 5G EPC. So this is the two paths. Some countries are following one path, another countries are following the different path. So let us see the 5G applications. So initially we would take a few use cases. One is automotive, mining, manufacturing, and transport. So in automotive, if we talk about the 5G will be used to develop end-to-end solution for future mobility and transport services. It would impact regularization and the standardization. So there are multiple companies, those are having the joint venture, the automotive company and the telecom companies, and they are coming together and developing the smart vehicles, you can say. If we talk about mining, mining has a very big problem. The people or the labor class, they have to go underneath the ground, and there is no signal, there is no safety measures there, and there is no technology that can we can use to get the parameters for the information from the mines. So 5G is also designed to address this kind of issues. So it would be capable enough to send that kind of signal, low energy signal, that would be even below the noise floor. So if it is even below noise floor, we would be still able to receive the signal in a correct manner. So that is the kind of vision 5G is having. So it should address that kind of requirement where the other technologies have not provided any solution so far. So here the Ericsson, ABB, and there are different companies that are working here. So this is for the critical control and the remote devices. Then we talk about the manufacturing industry, where we have to evaluate 5G and IoT to improve the production efficiency and to enable the data analytics. So all the data that is coming from all the industries, that should be sent to the cloud server, and we would be running data analytics to have the better production efficiency. In transport side, as a service offering, how we can do. So 5G is doing for the intelligent transport, and there are smart vehicles transport, and basically it is kind of the rental model. How can we run the rental models for the vehicles? So it is towards that side. So here we have listed down some use cases and what is the current scenario, what we are doing as of now, and what is the 5G would be providing, and what would be the ultimate experience with 5G. So here, if we talk about enhanced mobile broadband, current scenario is that we have screens everywhere. Either it is mobile or our laptop or anywhere, we could share the same screen, WhatsApp or any other application we can run anywhere. But after using 5G, we would be adding new tools like AR, VR. So after adding these tools, the experience would be immersive if we have AR, VR. If we talk about automotive, as of now, we have on-demand information. But after having 5G, we would be having real-time vehicle-to-vehicle communication. So this is towards the autonomous control, autonomous cars, autonomous vehicles. For manufacturing, we have process automation. Process automation is very old way of working. But after having 5G, we would be having flow management and the remote supervision. And we can have the remote control also. So it would allow us to have cloud robotics and the remote control. In energy and utilities, so far we were having metering and the smart grid. But after having 5G, it would be resource management and automation. The experience would be machine intelligence and real-time control. Healthcare, we have connected doctors and patient, but after having 5G, we can have like remote monitoring and medication e-care. Ultimate experience would be the remote operation. So doctors can perform the operation remotely also. So that could be possible because of having 5G. So quickly look into the autonomous cars. We know that autonomous cars having lot of sensors and devices inbuilt inside them. So similar to human body, where like we have a human brain that is getting data from all sensors, all body sensors, and it takes the decision in a fraction of. The same way here, there would be a centralized computing in autonomous car that would be getting data from different sensors, either it is camera, lidar, or sonar. So there are multiple sensors, and it has to take decision in a fraction of seconds so that possible accident can be avoided. And all this data has to be transferred to cloud also. Like terabyte of data would be coming per second or per minute. So that data has, we would be processing data at the central computing unit, and the important data would be shared to the server. The data that is would be used to control vehicle to vehicle communication, that would also be shared to the server side. So because of 5G, we would be moving from in vehicle to everything. So that kind of connectivity or that kind of facility 5G would be providing. So in autonomous cars, these are the like main interfaces that are being served in 5G, vehicle to vehicle. So it defines the set of rules, how vehicle to vehicle has to be driven, how the data would be shared in this case, vehicle to infrastructure, even the traffic signal that would also be transferring some data. That kind of vision they have. And then vehicle to network, real-time traffic and routing, this kind of things can also be done vehicle to network. So any vehicle would be sending data to network directly so that it can be utilized by other users. Then vehicle to pedestrians. So this vehicle has to be autonomous. It has to take care of all the pedestrian or any object that could come in front of the vehicle. These were the architecture side of 5G. Now these are let us discuss the key concept behind the 5G. So 5G, the millimeter wave, because of this, it is providing the flexible physical layer design. Then we have massive machine type communication, NB-IoT, and then distributed massive MIMO. So massive MIMO is used where there would be multiple antennas at the transmitter side and the multiple receive antennas. So because of having this kind of thing, we can have like data rate manifold. Then NFV and the SDN, beamforming, small cell, and 5G ultra dense network. So these are the cases where we complain that signal is not coming. So wherever the signal is not covered, because the signal that is transmitted generally takes the circular form. So there are some dark spots in between. So how those dark spots can be served, because for serving them we have small cells or the femto cells or hat nets. There are multiple terminology used in 4G, 5G. And then we would be having 5G mobile edge computing and fog computing. Then COMP, the coordinated multi-point connectivity, it is similar to the handover that we used to have in 3G, 4G. So how the user, when he is moving from one cell to another cell, one area to another area, how the call can be seamlessly transferred from one cell to another cell. Then the autonomous car and V2X. These are the key concepts that you would listen in 5G if you study. Let us see the 5G deployment. So 2020 was the headline date for 5G, but because of COVID issue, I think everything has been hampered now. So this date was chosen more than the political rather than the technical reason. So because this year Olympic Games was supposed to be held in Japan in July 2020, so they had planned to launch commercially 5G this year. And there is another reasons to be pushing 5G, that mobile operators, they want to be first in the new services. So in different countries, every mobile operator, they want to be first. And the Winter Olympic Games held in Korea, they have initially showcased the 5G. It was the test run. And the Rugby World Cup in Japan, it's September 2019. There also it was a test run. There is a 5G open trial specific alliance that is formed by SK Telecom, KT, NT Docomo. So these are the different operators from Japan, China, and USA. So they are still trying to speed up the deployment to meet the early deployment objectives. Because this 5G is meant for digitization, so all the industries they want to like share the information coming from all the industries to the server, and they can have they want to have better operating efficiency. So 5G is very much required for that. So if we see again the timelines, in 2017 it was planned to have simulation and prototyping. 2018 it was planned to have field trials and early drop. So here 2018 and 19 we saw that it was used in Japan and Korea for some of the games. And 2020 it was supposed to be launched commercially, and after 2020 it was like mass market services. That was the plan. So I hope the things will be covering very soon, and by next year we would be having full deployment of 5G in many countries. So let us see the 5G worldwide, what is the status. And first we should see what are the areas where the different companies are working into. So agriculture, John Deere and Husqvarna, these companies are working. Automotive, rail, factory automation, energy sector, environment, broadcasting communities, satellite communication, aerospace, retail sector, social media, advertising. So there are various kind of like industries that are participating, even the standardization part also. Earlier, up to 4G standardization, only the telecom companies were participating. But now, because of 5G, since it has to take care of all the industries, the various industries, they are also want to be part, because they can tell the unique requirements from their industry, and that can be taken care while they are designing the standards. All is being done by 3GPP. 3G partnership program. So this is the commercialization status as of now. By 2019 Q3, there were 76 operators in 51 markets. So the blue one is still under the planning phase. The red one, you can see there, the 5G is already commercially deployed up to some extent. In India, still we can see the blue one, it is still under the planning phase. So far we have discussed a lot of things about the technology requirement, different services it would be providing. Now, what are the barriers for 5G to become successful? So first of all, that 5G will be successful if the telecom industry, they should also talk to different industries. So like transport, healthcare, mining, exploration, utilities. So whatever industries they are making this standard, they have to bring them on the table, so that we can have a very good and stable standard from the beginning itself. And there are many political, strategic, and tactical challenges that can hold back the deployment of 5G. Sometimes we hear news about the health hazardness. That kind of issues are also like very prominent to deployment of 5G. Then there is the very big issue, the spectrum issue. In India, the reason of being delayed is we don't have the spectrum in that 30 gigahertz range. So this is the issue in multiple countries. So that spectrum should be free up. So then only the deployment and the licenses can be given. Business case. The business case should be very much clear to the industry that after having 5G, how the ROI would happen, and like what kind of advantage they would be having. So few of the industries, they understand, few of the players, they understand the need of 5G, but probably there is more work to be done to make everybody aware of 5G utilization. Then each government has to also act very fast in a unified way, so that it can bring up all the ministries on the same table to make the 5G successful. We should have the optical fiber backhaul. So if we talk about like high data rate, it cannot be possible if we don't have the back end ready for that. So at the back end side, we should have the optical fiber that can sustain this kind of data rate. Then the small cell deployment challenges. So this small cell concept has been very old. It is started from 3G point only. It means from 2000 time only, but still it has not become successful because it has a many deployment challenges. It is kind of ad hoc base station. Generally, whenever the base station is deployed, it has a lot of planning, like what is the interface coming from other base station, how many users it will be supporting, what is the cell area. Lot of things are there, how the handover would happen. But small cell is the like kind of ad hoc one. So if we place somewhere and it is creating interest to the external base station, or how it would be like behaving, how it would be connected to the core network. So there are multiple challenges that has to be addressed while deploying the small cell. So this is the thing that I would take you the setup that we have for 4G, 5G. It is basically for the hands-on purpose for the colleges only. So here in our setup, we have a software-defined radio based on RF, and it is Intel-based high-performance platform. So the base station is running on this Intel-based platform. Then the core network, the EPC part, that is running on one laptop. Uh, and then we have LCD based screen for display the whatever is happening, whatever signaling is happening from UE to base station to core network, we can see everything on the screen. Then Huawei dongle used to connect our LT network. So for UE part or for mobile part, we need one device. So we are using Huawei dongle for that one. But if we have a test user equipment, then we can make call from one mobile to another mobile also. So I will show you that how the setup looks like. So here the EPC, one EPC is running on one PC. Node B, the base station is running on another PC, and then we would be having two user equipment. That kind of setup we can have, so they can talk to different like to each other. So this is the setup we have. Here, this is the dongle that is connected to this laptop, and here we can see all the signals, the constellation coming at the UE side or the mobile side, and it is sending the RF signal, or this is the RF cable, and it is being received here over the by the E node B, and the E node B is further connected to the EPC. This is the core network. So here it would be sending all data, and finally it will be going to the internet. So here at the base station side also we can see the different constellation, different modulation schemes, or like error rate, CRC, and like how much throughput it is getting. So all that kind of information can come on the screen. And this is the like a graph we're seeing. This is the different physical layer parameters. We will not go into this one, but it shows that how the data rate is happening. There are different layers, 5 layer, RLC is the RLC and RRC. So layer 2, layer 3, at different layers, how the data packets are being formed. So everything we can visualize here. So this is the thing from my side. So we can go for the question and answer session now.
Now I request the participants to raise their hands so that you can interact with Kaushal sir. So there is one question from Kasiamal madam. She's working in AC department in our college. She's asking, okay, is there any real-time application for remote operation either in India or in any other country?
Yeah, in India, as of now, we don't have, but other countries, they have started like having running some tests, because this the healthcare is still very critical part. There is some applications, but in limited scope. We have not run the full-fledged operation based on 5G as of now.
And one more question is from Ravindra sir. He's asking, what are the major advantages that are going to be happen with 5G in education field?
Education field. Okay, so that is a good question. Okay, so education field, I think the sharing of knowledge would be the part. If we talk about AR, VR, we started using for the education purpose. We can like, instead of reading everything or we studying the theory part, the same thing can be practically, we can experience by using AR, VR. That would really help in this scenario when we are having COVID, everybody is sitting at home. they cannot perform any kind of hands-on kind of thing. Kind of things can be used if we have AR, VR.
So one more question from Archana madam, sir. She is asking, what about the radiation effect as 5G
Yeah.
requires more number of antennas?
Yeah. So radiation is a big issue. That is lot of studies happening. They are trying to find some workaround so that we can transmit the power at lower power. So the kind of modulation we would be using, had it, we were be using 4G with the same requirement, we would be like transmitting with high power. But once we have right modulation schemes, right coding schemes in 5G, the same thing can be done with lower power. So there is lot of work happening towards the power side also, that we can transmit with low power. But still, it is a big concern because lot of antenna, lot of radiation would be happening.
Noor Ahmed, sir, can you unmute yourself?
Good evening, sir. My question is, what impact does 5G have in rural India if it starts?
Rural India, as we would be having IoT deployed. Okay, so IoT is meant for the low cost devices. So overall idea to have 5G is that we can have the connection at very low price. If we 5G is there, I think rural India would also be benefited very much, because we would be having lot of services in rural area in that case, and it would be very cheaper. So generally we talk about that per bit, what is the price we have user has to pay. So in 5G it would be much lower than 4G. Like 4G we have, because of the packet formation, instead of the circuit switch, we are using packet switch, right, in 4G. So the cost has become drastically reduced in 4G. The same way from 4G to 5G, I think it would be 10 times lesser than 4G. So once the price of connection is very less, and we would be having cheaper devices for any application that is required in the rural side, we would be, even like we are having some agriculture side. We are deploying, we are working on the smart agriculture. We are providing some solution based on the LPWAN, the LoRa technology. But if 5G is there, it would replace that kind of technology. It would be even cheaper. And moreover, the 5G would be removing the problem of the data connectivity. In 3G, 4G, we have an issue that all the rural areas are not fully covered. But with 5G, after coming 5G, it would be like having a full deployment at rural side also. So we would be like, there is a huge problem of electricity and other things, but the 5G would be addressing the battery issues also. Like the power consumption from the devices should be as low as possible. So the devices that would be running for the IoT applications, they should be able to run for 10 years, 20 years with the battery. So 5G is working in that direction also. So very small chunk of data, if it has to be transmitted by the device, it can be done with very less power consumption. And moreover, signal quality is also like maintained very well in 5G. So even if the signal would be transmitted even below the noise floor, with a very low power also, the signal can be transmitted, can be sent to a very far.
The Gajendra Singh, sir.
Yes, ma'am. My question is, how 5G helpful in IoT? And the related question is, LoRaWAN is a technology of 5G or different from 5G?
LoRaWAN is a competitor of 5G. LoRaWAN is meant for ad hoc network or the private network. Okay, so it is kind of, you can say, competitor for the 5G. But 5G is taking care of whatever LoRaWAN is supporting. Everything would be supported in 5G.
Okay, sir. And how 5G will helpful for IoT? And what are the main things that have to adopt by the IoT?
So see, the major thing that is the battery life, as I told, battery life and the signal. So even with a very low powered signal, we would be able to communicate from transmitter to receiver by using 5G, and battery life will be very much 10 to 20 years if you need not to change the battery. So it means you can put your device any such a place where you don't visit so often, or you don't want to go, nobody goes for 1 year, 2 year or 10 years, nobody wants to go. So that kind of places also you can you can start monitoring the different kind of parameters. So even if we talk about building management also, there are a lot of the water valve, they are inside that building. and nobody goes to see them. Put the devices there, so it would be like very easy. Or we can talk about the wiring or the piping that is being laid underground. Okay, so if we put the devices there, small device to detect the leakage, nobody now, otherwise who will go and dig after some time to check if there is any leakage or not. So if we can put some device, and that is also capable of sending the signal even it is underground, say up to 10 meters or 20 meters or 50 meters, and still it is able to send the critical parameters to the server. So it is very useful. So that kind of vision 5G has, that kind of facility 5G would be providing, that the device can be put in such a place where like human approach is not so easy each and every time. So the for multi-purpose 5G would be very useful.
Anurathan Kare, sir, can you
Yes, sir. Good evening, sir.
Yes, sir. Yeah.
My question is, what impact will 5G have on black hole network?
Okay, backhaul network you mean?
Yes, sir.
Okay, yeah. So backhaul network, see, up to some extent, it has to utilize the same backhaul network that 4G is providing. But
Okay.
after like if we have to make a complete new architecture, then this backhaul network would be little bit replaced.
Okay.
Okay, so but generally the idea is that uh, the operators, they always want to have whatever changes has to be done, that should be done on the radio interface. Radio interface is the one that is between UE, the mobile, and the base station. So there, if there is some changes, it is like bearable. But lot of changes at the infrastructure side or the backhaul network side, then it would be a big issue. But definitely enhancement would be needed. Like I told that optical fiber has to be laid down for having 5G. So that kind of enhancement where we can like support up to gigabits per second data rate. So that kind of enhancement is really required at the backhaul side.
Rajkumar, sir?
Sir, is there any smart vehicle or connected vehicle applications are implemented in any smart city of India?
In India, right now we don't have, because we don't have the 5G network. So there is no, as such, the smart vehicle or the connected vehicle kind of thing has been, or the autonomous vehicle, that kind of thing has been done.
Thank you very much, sir. Kaushal, sir, you have given a very nice presentation regarding the 5G.